Dear physics aspirants, right now I have the 12.6 of physics and physics atoms. When you study the atoms chapter, then you will get the D. Broglie's explanation of Bohr's second postulate of quantization. So here is the picture, and I would like to provide you the information of all the postulates Bohr made. This moral of the atom, perhaps the most puzzling, is the second postulate. It states that angular momentum of the electron orbiting around the nucleus is quantized. That is, ln is equal to nh by 2 pi and n is equal to 1 to 3. Why should the angular momentum have only those values that are integral multiples of h by 2 pi? The French physicist Louis de Broglie explained this puzzle in 1923, 10 years after Bohr proposed his model. We studied in chapter 11 about the de Broglie's hypothesis that material particles such as the electrons also have the wave nature. CJ Division and LH Germer later experimentally verified the wave nature of electrons. In 1927, Louis de Broglie argued that the electron in its circular orbit as proposed by Bohr must be seen as a particle wave. In analogy to web traveling on a string, particle webs too can lead to standing webs under resonant conditions. From chapter 15 of class 11 physics textbook, we know that when a string is plucked, a vast number of wavelengths are excited. However, only those wavelengths survive which have nodes at the ends and form the standing wave in the string. It means that in a string, standing wave are formed when the total distance traveled by a wave down the string and back is one wavelength, two wavelengths, or any integral number of wavelengths. Waves with other wavelengths interfere with themselves upon reflection, and their amplitude quickly drop to zero. For an electron moving in nth circular orbit of radius Rn, the total distance is the circumference of the orbit 2 pi Rn. Thus 2 pi Rn is equal to n lambda, n is equal to 1 to 3. Figure 12.10 will illustrates a Figure 12.10 illustrates a standing particle wave on a circular orbit for n is equal to 4 ie. 2 pi Rn is equal to 4 lambda, where lambda is the de Broglie wavelength of the electron moving in nth orbit. From chapter 11 we have a lambda is equal to h by p, where p is the magnitude of the electron's momentum. If the speed of the electron is much less than the speed of light, the momentum is mv, and thus lambda is equal to h by mv. And from equation 12.24 we have lighted as we have 2 pi Rn is equal to nh by mvn, or mvn Rn is equal to nh by 2 pi. This is the quantum condition proposed by the Bohr for the angular momentum of the electron. Equation 12.13 in section 12.5 we saw that the equation is the basis of explaining the discrete orbits and energy levels of the hydrogen atom. Thus the Broglie hypothesis provide an explanation for Bohr's second postulate for the quantization of angular momentum of the orbiting electrons. The quantized electron orbits and energy states are due to the wave nature of the electron, and only resonant standing waves can persist. Bohr's model involving classical trajectory. Picture planet-like electron orbiting the nucleus correctly predicts the gross features of the hydrogenic atoms, in particular the frequencies of the radiation emitted or selectively absorbed. This model, however, has many limitations. Some are the Bohr model is applicable to hydrogen atoms. It cannot be extended even to mere two electron atoms such as helium. The analysis of atom with more than one electron was attempted on the lines of Bohr's model for hydrogenic atoms, but did not meet any success. Difficulty lies in the fact that each electron interacts not only with the positively charged nucleus but also with all other electrons. Here is the topic you will see here. I have discussed with the help of this NCERT book. You can see here. So the momentum, the formulation of the Bohr's model of involves electrical free force between positively charged nucleus and electron. It does not include the electrical forces between electrons which necessarily appear in multi-electron atoms. While the Bohr's model correctly predicts the frequencies of the light emitted by hydrogenic atoms, the model is unable to explain the emitted by hydrogenic atom. The model is unable to explain the relative intensities of the frequencies in spectrum emission spectrum of hydrogen. Some of the visible frequencies have weak intensity, others strong. Why experimental observations depict the some transitions are more favored than others. Bohr's model is unable to account for the intensity variations. Bohr's model presents an elegant picture of an atom and cannot be generalized to complex atoms. For complex atoms, we have to use a new and radical theory based on quantum mechanics, which provides a more complete picture of the atomic structure. Here is the laser light you will see here. We will meet in the next sheet with lot more. Till then, thank you.